Okay. Yesterday, at the end of class, I tried to explain why I needed you to go back and forth from radians and degrees. Just let me put that example back up here. I said to you, all right, let's just say, I forget what the radius length is, but let's say the radius length is 4, and my angle is 2 pi over 3, and I'm going to ask you how long the arc is, the arc length. So let me review that with you. From our day 2 discussion, day 2. So if you need to look it back up, look it up because I'm going to ask somebody. Length of an arc. That formula for length of an arc from day 2. There's only one way I know how to find the length of an arc. Using this formula, which says what? Here we go. Hannah, what's that formula say? Length of an arc is equal to what?
I'm 22. No, 21.
20. Who am I missing? 1, 2. Who am I missing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ellie, 13, right?
No, I'm 13.
It's me.
I'm just trying to figure out how my numbers went wrong.
Yeah, I'm 14.
Me 3, 8 and 4, right?
I'm 5.
That's right, because we had somebody drop, so I need. All right, sorry about that. Go ahead, whoever. Sorry, go ahead. Length of an arc.
Measure of arc over 360 times pi diameter.
Thank you. Here we go. Now, but here's the thing we said yesterday. Whatever you plug in there has to be in what type of units? Degrees, degrees, degrees. All right, well, what's the problem here? What did I give you? The angle's in what? 2 pi over 3. That's in what? Radians. So I can't plug it in for x. Everyone see, in this problem I have up on the board, you cannot use this formula. Unless you do what? Take 2 pi over 3 and do what with it? If I need degrees, what can I do 2 pi over 3? Okay, that's fine. The silent treatment's good for me too. 6.
You multiply it by 180 over 5.
Convert it into degrees, right, Caroline? Convert it into degrees. Well, what I'm going to do right now is, maybe you're not comfortable converting. All right, maybe one day isn't good enough for you. You're not comfortable converting radians to degrees or vice versa. So what I'm going to show you right now is, if the angle is already in radians, there's a formula you can use. Okay, instead of converting to degrees and using the day 2 formula, there is a formula you can use to find arc length if it's in radians. And here it is. It is a very short formula. Maybe some of you would prefer it over day 2 formula. It says the following. Theta, just so you know what I'm referring to, theta is your central angle in radians. That's your central angle in radians. Is equal to S, which is your arc length, over R. And what do you think R is? Same thing as R in circumference. That would be my radius length. It's going to serve the same purpose as the day 2 formula. It will find you the length of an arc, but now your angle's in radians instead. So I don't know. We'll see. Today is all about options, guys. Options. What do you like better? Day 2 formula or this theta equals S over R? You just got to make sure you're in the right unit, radians or degrees. So look at number 1 right now. Number 1. Anybody see what's our angle in? Radians or degrees? Radians. So maybe some of you want to use this new formula. Theta equals S over R because it's in radians. Maybe some of you really like the day 2 formula I just went over. If that's the case, what are you going to have to do to pi over 3? Convert it. This is your choice today. Your choice. You're going to get the same answer either way. So here we go. My angle in radians is pi over 3. I plug that in for theta. S is my arc length. That's what I'm asked to find, so I'll keep it S. Over my radius, which is 5. How are you going to solve that for S now? How are you going to solve that for S? I don't even know. I still got to keep it. You know what I'm going to do? Three, 5, 6, 7, 8, 9, 10, 11, 12, 13. Ellie, 14?
Yeah.
Good. 15, 16, 17, 18, 26. Okay, there we go. We're all business now. There we go. 8. Ryan, how are we going to figure out what S is?
Would you multiply by 5?
You can multiply both sides by 5. You can cross multiply because there is an equal sign in between now, right? So I can get 3S equals 5 pi. If I cross multiplied, divide both sides by 3. S is going to be equal to, we're rounding, correct, to the nearest hundredth, 5.24 centimeters. Maybe you don't like it. Again, instead, let me go back. You can use this formula, guys, right here. Hey, you can use this formula right here if you want instead. But before you use that formula, you might want to take pi over 3 and convert it. Okay, take pi over 3, convert it into degrees, and use it in the formula. You are still going to get the same exact answer. Choices today, choices, whatever you feel comfortable with. I'm going to keep using this new formula because that's what I'm teaching you. So, all right, next one. Find arc length S, 10 pi over 9. Oh, it's in radians. So if it's in radians, I can use my theta equals S over R formula, or I can turn 10 pi over 9 into degrees and use the day 2 formula. That's it. Those are your choices today. Feel comfortable with one of them, hopefully. So theta, my angle, 10 pi over 9. Looking for arc length S, while the radius is 27 meters. And here I go again, cross multiply. 9S equals 10 pi times 27. All over, and then I divide both sides by 9. And round to the nearest hundredth. Questions? So you got 2 formulas now to find arc length. One if you're given radians, one if you're given degrees. Do you need to know both? No, you don't. But you better have the ability to convert back and forth if you're only going to focus on one of them. All right, here we go. Next up. Now find the angle. Find theta. Find the central angle. In radians and degrees. Ooh, okay. So I got to find it in both now. I'm going to find it in radians first because that's the formula I've been showing you guys today. If you want to find it in degrees first, again, I'm going to keep harping on this. If you want to find it in degrees first, here's the formula you use. You solve for x in the formula if you want to find degrees first. All right. I just find it easier for me, maybe easier for you if we start out with theta equals S over R. All right, so the angle, theta, that's what I'm looking for, is equal to arc length, which is 8 pi over radius 16. Now remember, you guys, hey, you are finding this angle in radians. Do I want that long sloppy decimal that's on your calculator when you do 8 pi divided by 16? No. I want radians in terms of pi. So I leave the pi there, and I just simply reduce 8 over 16. So that central angle in radians will be 1 pi over 2. That's in radians. Now I want it in degrees now. So you guys have two options, right? You either convert pi over 2 right now like we did yesterday, or you go to the day two formula and solve for x. One is definitely quicker over the other, but I definitely want you to do what you're comfortable with. So we could take pi over 2 and convert it, or you can use your day 2 formula, plug everything in, and solve for x. Let's convert it. I'm going to convert it. Here you go, pi over 2. If I'm going to convert it to degrees, what's the conversion to multiply by? 19, here we go. Sean, what do I have to multiply pi over 2 by to turn into degrees?
180 degrees over pi.
180 over pi. Perfect. Pi's cancel, everybody. And I'm left with 180 divided by 2. So pi over 2, the same as 90 degrees. So that angle is 90 degrees.
So how would you know about doing divide?
How would I go about it?
Yeah, like how would
Sure, here you go. What's the length of the arc?
8 pi.
Okay, so here we go. 8 pi equals x, what I'm solving for, over 360 times pi d. Pi, what's the diameter? 32? Okay, I do notice that I have pi's on both sides, right? So when I divide both sides by pi, they're going to cancel each other out, right? So the pi's are gone. Oh, okay, I don't know what happened there, but okay, this is fun. This is fun. There we go. I don't know what happened there. Sorry, guys. All right, going back, the pi's are going to cancel out, right? So I'll have 8 equals x over 360 times 32. And we did a couple of these in homework yesterday. You can multiply both sides by 360, then divide by 32. Or you could divide by 32 and then multiply by 360. You'll still get 90 either way. Okay? So that's how you could have done it without converting the pi over 2 to degrees. Questions? Okay, go ahead. Try out the next one now. Actually, I probably should try this one out with you here. Yeah, I will. All right, same thing. Find the angle. Let's find it in radians first. So theta equals S over R. So theta is going to be equal to 15 pi over 7 divided by the radius 5. Ooh, that looks nasty, doesn't it? That looks nasty. Radians, always in terms of pi. Take the pi out. Hey, everyone, take the pi out. And now, what is 15 over 7 over 5? Oh, boy. Good thing we got one of these, huh? 15 over 7 over 5. Okay, so I got to put 15 over 7 on top, so I need another template. Look at that, huh? I don't know if some of you knew that. We didn't even know copy paste, but 15 over 7 divided by 5.
How do you get that template?
Okay, yep, ready? Just get your fraction template up, right? Numerator, denominator. And then I put another one in the numerator. Yep. You get 3/7. 3/7. Or, another way too, you could put 15 divided by 7 in parentheses and then divided by 5. That's another way. And then turn that into a fraction. That's another way if you don't want to use the double templates there. So in radians, that angle's 3 pi over 7. So in radians, it's 3 pi over 7. What about in degrees now? Round to the nearest tenth here too, please. All right, round to the nearest tenth. You got 3 pi over 7. Let's round to the nearest tenth. When you convert it to degrees, and you guys finding in degrees about 77.1. Any issues converting? Everyone at home all right? All right, pendulum. Had to Google pendulum and images today and broke that one out. I didn't know if people knew what a pet clock pendulum was or not. All right, but that's it. It's like a big grandfather clock that swings back and forth. This one swings through an angle of 2.5 radians. So as it swings back and forth here, back and forth, back and forth, back and forth. All right, it swings through an angle of 2.5 radians. Okay, forms an angle of 2.5 radians. And you could just think too, if you want, here's the pendulum as well, swinging back and forth. All right. How far did it swing? 50 centimeters. It made an arc length of 50 centimeters. What's the length of the pendulum? Can anybody know geometry term for the length of the pendulum? What it's asking me to find? The length of the pendulum. That's another name for the what here?
The radius?
Radius length. Yep, that's the hey, think about it. Hey, if I keep drawing this all the way around this circle, this thing is killing me today. Circle, everyone see? We're talking about a radius length. Okay, the length of the pendulum is the same as the radius. All right, we can do this. Angles in radians. Angles in radians. So I can do theta equals S over R. If you prefer, day 2 formula, change 2.5 to degrees. It's up to you. So 2.5 is my angle, so that's in for theta. Arc length is 50. What's the length of the pendulum, aka the radius? And I can once again cross multiply. "20 centimeters. 20 centimeters. Questions, comments? All right, take a look at number 6. Go ahead, take a look at number 6 on your own. Central angle, meaning it comes from the center. That was day 1 vocab. Central angle, excuse me, day 2 vocab. Comes from the center, measures 3.5 radians. And the arc length is 24.5. Find the diameter. Ooh, diameter, huh? Let's see what you got there. Find the diameter.
So will we need to know both ways of finding number?
No, but you got to know how to convert. Like say you love this theta equals S over R formula. It's always has to be in radians then. So if I give you a problem in degrees, you got to make sure you can convert that degree to radian, then use the formula. So that's what's nice. You don't have to remember both formulas. All right, so you guys have 3.5 in for theta. S, 24.5, arc length over R. We cross multiply. We know R equals 7, but it did say find the diameter. Read it carefully. So my diameter will be 7 times 2, 14 centimeters. Okay? All right, let's wrap this all up now. There are both formulas there at the top of your page. Both formulas. Both formulas. And just to prove to you that we can do both, here's what I'm asking for. You see the radius is 2.40, central angle of 165. Or ask for the length of, hey, there's another vocabulary term, right? Minor arc AB. So the one that's less than 180, okay, minor arc AB. Calculate it two ways for me. I want you to calculate it using radians, and I want you to calculate it using degrees. So why don't you first start with degrees, because that's what's given. So what's the length of that arc using 165? And then turn it into radians and find the length of the arc. And hopefully, I'm hoping you come out with the same response here. Okay, we should come out with the same answers here. So go right ahead. Calculate the arc length using degrees, convert it, then calculate it using radians.
So once you get an answer that is in radians, then you have to calculate that with pi in order to see if it.
Say that again.
You need to get like a whole number answer, right? You can't leave your answer in pi. Or...
Why would you leave? Well, it says you're finding arc length, right? The only thing that should be left in terms of pi is radian measure, angle measure, radians. Okay, you guys can see my work up here. Degrees, I just plugged in 165 to that day 2 formula and got 6.9 when I multiplied everything. Then I converted 165 to radians by multiplying by the conversion from yesterday, pi over 180, and got 11 pi over 12. That's how many radians are in 165 degrees. I plugged it into theta, and theta equals S over R. Cross multiplied, and also got 6.9. The only thing I watch out for, and I say this because I made this mistake this morning when I was doing the notes, is make sure when you're using the degree formula from day 2, it's pi d. Pi d. I accidentally plugged in 2.4 here because I had one job and didn't do it. All right, you had that's the radius, but in the formula it says pi d. Pi d. Any questions, comments, or concerns? Bottom line, you don't need to know both formulas. Know what you're comfortable with. All right, use what you're comfortable with, but be able to make sure you can convert in the proper units if you need to. All right, guys, that's all I have for you. You guys at home are all set. You guys here can continue on in your packet. All right, I'll see you guys tomorrow.